Today we are going to discuss on the topic of the chemical reaction and balancing of reaction. Now this topic is important for the various competitive exams and also for class 10 and 12. Now first of all, what do you mean by a chemical reaction? See, a chemical reaction is a reaction in which the reactants will react to give a product. Now, what is a reactant? Example, take an example of a chemical reaction. Carbon plus oxygen will give to carbon dioxide. Now, the reactants, which is in the left hand side, these are called as the reactants. And the reaction that has proceeded and which have formed a new substance is called as the products. Now, what do you mean by balancing? See, balancing means the number of the atoms in or the reacting species which is in the reactant should be equal to the number of the reacting species in the products. Now, why do we need to balance the chemical reaction? We need to balance the chemical reaction to fulfill the law of conservation of mass. So what is the law of conservation of mass? The law of conservation of mass states that atoms cannot be created nor destroyed, but can be only transformed from one form to another form. That means whatever the number of the reacting species or the number of atoms in the left hand side, that is your reactant, should be always equal to the number of atoms in the product. So to obtain that law of conservation of mass, we need to balance the chemical reaction. So now we will discuss about the type of chemical reaction. There are various types of chemical reaction. We will arrange it as these. The first one is called as a combination reaction. Combination reaction, as the name suggests, combination reaction is a reaction in which two or more reactants or the reacting species will react to form a single product. It's called as our combination reaction. So example, carbon plus oxygen giving rise to carbon dioxide, which is called as our combination reaction. Our calcium oxide, when we react with water or mix with water, we will get calcium hydroxide. This is called as our combination reaction. The second type of reaction is decomposition reaction. Now, as the name indicates, decomposition reaction is the opposite of combination reaction. That means here, in this particular decomposition reaction, single reactants will react to give two or more products. This is called as our decomposition reaction. Example, when we heat our copper chloride, we will get copper plus chlorine. So here also we have certain examples like when we react our ferric sulfate Fe2SO4, we will get our ferric oxide Fe2O3 plus sulfur dioxide and SO3, sulfur dioxide. So this is our decomposition reaction. The next is our displacement reaction. Now in displacement reaction, this type of reaction are those reactions in which one of the reacting species will displace the another reacting species. That is called as our displacement reaction. Example, we have iron in copper sulfate. So whenever this reaction proceeds, this iron will displace our copper. So we will get ferric sulfate plus copper. So this is called as our displacement reaction. The last one is our double displacement. Double displacement reaction. In this double displacement reaction, this is also the same type as a displacement reaction. But what is the difference is that in this particular displacement reaction, only one of the element is being displaced. Whereas in the double displacement, double means two of the reacting species will be displaced. So here also we have certain examples like Na, sodium sulfate plus barium chloride. When we react, the particular sodium will displace our barium. So NaCl2 plus PaSO4. So this is called as our double displacement reaction. See, in certain type of chemical reaction, there are the heat that is being released and at the same time the heat are being absorbed. So the next thing is that the chemical reaction also can be classified based on the absorption of heat or the evolution of heat. That is called as our endothermic and exothermic reaction. So what do you mean by endothermic and exothermic reaction? Endothermic reaction is a type of chemical reaction which involves the absorption of heat. That means the reaction will proceed with the absorption of heat. And we have on the other side the exothermic reaction. In exothermic reaction, the reaction involves with the release of heat. So we have our next topic that is called as oxidation and reduction. And reduction. Oxidation is a reaction or chemical reaction in which oxygen is being added or hydrogen is released. In certain modern textbook, we have oxidation involves the losing of electrons. In the reduction, we have reduction means losing of oxygen or gaining of hydrogen. Or in the new term we have reduction as the process involves with gaining of electron. It's called as reduction. See, I will show you some example for oxidation. Oxidation. So when we have copper, it is burning oxygen, we get copper oxide. So that means this particular copper have absorbed or have gained oxygen, which is called as oxidation. We'll see the example of reduction. So in reduction, when our copper oxide, when reacted with hydrogen, we will get copper plus water. Now see, this copper, the oxygen is being reduced, so we call it as a reduction. We also have certain chemical reaction which involves both oxidation and reduction. That we call it as a redox reaction. Now we will look into how to balance our chemical reaction. You see, we have lots of problems how to balance our chemical reaction. But with these simple tricks, you'll be able to balance even if the problem is very complex, you'll be able to balance it. So how do we balance it? First of all, you balance the metal. Balance the metals. Then balance the non-metal. After balancing the non-metal, check whether the metal is balanced or not. After that, balance the oxygen. Similarly, after balancing the oxygen, check whether your metals as well as your non-metals are balanced or not. And the fourth one is balance the hydrogen. Similarly, after balancing the hydrogen, check whether your oxygen or your metals or non-metals are balanced or not. By using this technique, you will be able to balance any chemical reaction. So let us look at some example. We'll balance these particular problems. Calcium hydroxide. So calcium hydroxide is CaOH2 plus carbon dioxide CO2 will give to calcium carbonate plus water H2O. So we will follow the technique. First of all, we will balance the metals. Here our metals are, we don't have any metal, but we will now we will balance the non-metals. So calcium is a non-metal. We have carbon, non-metal. So we'll first of all we will balance the calcium. So calcium 1 here, here also it is 1. So it's already balanced. Now we'll see for carbon. Carbon here it is 1, here it also it is 1. Now we'll balance the oxygen. Oxygen we have seen this whole, that means oxygen we have 2 plus 2, 4 in the left hand side. We will check in the right hand side, 3 plus 1 is also 4. So it is also balanced. We will see our hydrogen, H2. Here also it is H2. So our chemical reaction is balanced. Now we'll balance this particular problem. Sodium hydroxide NaOH plus sulfuric acid H2SO4 give rise to sodium sulfate Na2SO4 plus water. Now as I told you, first of all we'll balance the metals. Here sodium is our metal. So you see in the left hand side we have 1 sodium, whereas in the right hand side we have 2 sodium. So it is not balanced. So I will just put here 2 Na. Now our Na is balanced. Next thing we'll check our sulfur S. Sulfur you see here 1, here also it is 1. So it's balanced. Now we will balance the oxygen. So we see the left hand side, 2 oxygen plus 4 oxygen becomes 6 oxygen. In the right hand side we have 4 plus 1. So it is not balanced. So I'll just put here 2. So 4 oxygen, 2 oxygen, 6 oxygen. Now we will check. 2 sodium, 2 sodium. 1 sulfur, 1 sulfur. Oxygen you see 2 plus 4, 6 oxygen. Here 4 plus 2, 6 oxygen. Now we will balance the hydrogen. 2 hydrogen plus 2 hydrogen becomes 4 hydrogen. In the right hand side we have 2 to the 4, 4 hydrogen. That means our hydrogen is also balanced. So now we'll try to balance this particular problem. Barium chloride plus sulfuric acid gives to barium sulfate plus HCl. First of all, we will balance our metals. The metal is barium. So Ba in the left hand side only 1. In the right also we have only 1 barium. So it is balanced. Now we have chlorine. You see chlorine, 2 chlorine in the left hand side. You have only 1 chlorine in the right hand side. So you just put 2 chlorine. Now you check. Your barium is balanced. 2 chlorine is balanced. Now we'll see the sulfur. 1 sulfur in the left hand side. Here also it is only 1 sulfur. So it is balanced. The next is we need to check for oxygen. So you see oxygen, 4 oxygen in the left hand side. We have 4 oxygen in the left hand side. That means our particular problem is balanced. So this is how we balance our chemical reaction. Thank you.